Hello, my name is Stephanie Huff, and today we're going to talk about alkyne hydration reaction mechanisms. So just an overview. First, we're just going to review what an alkyne is, and then we're going to dive into the two types of alkyne hydration reactions. They both have two different reagents. And then I'm going to explain the tautomerization and the product of these reactions. What is an alkyne? An alkyne is any hydrocarbon molecule that contains at least one triple bond. I have an example here. This is just a simple bond line. And because the triple bond is sp hybridized, it's always going to be linear. So this is a 4-carbon molecule. 1, 2, 3, 4, not a 3-carbon molecule. Because it's linear, we have a carbon here and a carbon here, and you will never see an alkyne represented this way. This is incorrect, and that's a good way to lose a lot of points. So let's dive into our two types of reactions. The first one, I like to think of this alkyne hydration reaction as being very similar to an acid-catalyzed hydration and the oxymercuration of alkenes. So if you can recall back to when you learned that and the specific mechanism, it is represented almost exactly in this alkyne hydration reaction. So the reagents, in this one we use HgSO4 as a catalyst with an acid, always H2SO4 and water as reagents. This produces a Markovnikov product where OH, the alcohol group, is going to add to the more substituted carbon, and the hydrogen is going to add to the less substituted carbon. So I have an example here. We have our alkene, we have our HgSO4, H2SO4, and water, and it is going to produce a Markovnikov product. So when we rewrite it, it's not going to be linear because there's no longer that triple bond. This is an alkene. And we have our alcohol group on the more substituted carbon. The second type of alkyne hydration reaction, I like to think of this one as the hydroboration of alkenes, because again, that reaction mechanism is represented almost exactly in this alkyne hydration reaction. So the reagents for this one, it is 2 steps. The first step is going to be a boron-containing reagent and THF. So a lot of times you'll see BH3 or just a very generic form R2BH. It just has to have boron and 1 hydrogen. So the other 2 groups, really could be whatever. The second step has a peroxide, a base, and a water. So just like with alkene hydration reactions in the hydroboration of alkenes, this is going to produce an anti-Markovnikov product where OH is going to add to the less substituted carbon and the hydrogen is going to add to the more substituted carbon. Here's our example. Just like I talked about before, we have an R2BH, very generic, and THF, and we have peroxide, the base, and the water, and our anti-Markovnikov product. We have our OH added to the end here, the least substituted carbon, and an implied hydrogen over here. So I just want to mention that these two products are not the final products of this reaction. And here's why. There's something called tautomerization. So what is a tautomer? Tautomers are specific isomers that are either enols or they can be ketones and aldehydes. So it's either an enol or a keto, and the ketos can be aldehydes too. Tautomerization is the process by which one isomer becomes another, and the keto tautomer is the most stable in a linear molecule. So I have an example of the enol tautomer, and where we get this name enol is because of this alkene, this double bond here, alkene, we get the ene, and we have an alcohol group, we get the ol, and that's where we get the enol from. And then the keto form is just representative of the functional group ketone, and it can also be an aldehyde. say if this was a terminal, if this double bound oxygen was over here, this carbon is bound to this carbon, and then 2 bonds to oxygen, and that leaves 1 more bond, so there's going to be hydrogen there, and that's what an aldehyde is. So for the 2 types of alkyne hydration mechanisms, we cannot forget that keno-enol tautomerization occurs. So here's our first type of alkyne hydration reaction, in which we have our HgSO4, H2SO4, and water as our reagents. And this is the enol product that we got. The enol product is less stable than the keto. So the ketone product is going to be your final product. So this is how it happens. And don't forget, this is an acid. So when I'm explaining how the enol isomer goes to the keto isomer, this is going to be in an acidic solution. So this double bond reaches out and grabs a hydrogen at the same time that this oxygen forms a double bond with this carbon. Now the oxygen is positive, it's unhappy, so another water molecule grabs this hydrogen off of there, and here we have our keto product. The keto is most stable. So for our second type of alkyne hydration reaction, seen here, this is exactly what I had up earlier with the boron-containing reagent in THF in step 1, and step 2 having the peroxide, the base, and the water. Here we have our enol. This is a terminal enol. And again, I just want to point out that the NaOH, this is a basic solution, so I'm going to show you how the tautomerization occurs in the basic solution. So here's our enol again. In the basic solution, we have excess OH minus, which is going to go ahead and grab this hydrogen, and this bond's going to collapse on the oxygen. Simultaneously, this double bond is going to reach out and grab a hydrogen on the water, and that gives us our aldehyde product. So there's an implied hydrogen there. So I just want to lay it out, give you guys the full scope of everything that we talked about. These are the 2 types of alkyne hydration reaction mechanisms. And you can see when you're presented with a problem on a test or homework and you have an alkyne and you have these reagents, you can give the product as the keto tautomer. Just know that it's automatically going to occur in linear molecules, and this is your answer. So same with this one. When the keto-enol tautomerization occurs, this is your product here. My professor really doesn't require us to write these, but it is important to understand the how and the why, so you can, fully understand the concept here. So thank you so much for watching. You guys have a great day.